So today's lesson is all about changing the dimensions and of an object and seeing what impact that has on the volume of that object. So here we go. Here's an example. A company makes chocolate spheres that have a radius of 3 centimeters. For the holidays, they make a special edition chocolate that has a radius that is twice as big. Determine the volume of the regular spheres. So the formula for the volume of a sphere is 4/3 pi r cubed. So 4/3 pi times 3 cubed. 4/3 times pi times 27. And now we're going to go ahead and figure out what that is. 4 divided by 3 times pi times 27 is 113.10 centimeters cubed. That's the volume of a single chocolate sphere. Now, going back to the question does say that for the holidays they basically make a special edition that has the radius that's twice as big. So we're doubling the radius. Let me ask you something. What do you think that's going to do to the volume if we double the radius? What do you think is going to happen to the volume? So volume is still 4/3 pi r cubed. Now, though, instead of a radius of 3, we've got a radius of 6 because the radius was doubled. If we follow order of operations, we're going to figure out what 6 cubed is first. So that's 6 times 6 times 6. And 6 times 6 times 6 is 216. So now we're just going to go 4/3 pi times 216. And that gives us, holy man, 904.78 centimeters cubed. Wow. So if we take a look at the original volume and we compare it to the new volume, that is times 8. So it's 8 times bigger. Just by doubling the radius, the volume is 8 times bigger. Okay? 8 times bigger. Now, it doesn't ask us. It doesn't ask us how much bigger does it get. But if you want to answer that question, all you need to do is take the volume down here and divide it by the volume up there. And what you're going to get, I believe, is probably something like 7.9999999 or something like that. So it's 8, right? So it's 8 times bigger just by doubling the radius. Now, we'll have to see what effects other things can have when we change other dimensions in, say, the next example. So let's go to the next example. And here we see that we've got a pyramid. All right. Ooh, I love this question. This is a great question. Recreation company makes tents in the shape of pyramids. Here's our pyramid. So it's an 8 by 8 square bottom. It doesn't say it has to be a square bottom, does it? No, it doesn't say it has to be a square bottom. And the height's 9. Cool. What's the volume of the pyramid? So the formula for the volume of a pyramid is volume is 1/3 length times width times height. That could be our length, that could be our width, and the 9 feet is, of course, our height. So it's going to be 1/3 of 8 times 8 times 9. And, well, 8 times 8 is 64. And then basically, it's going to end up being, I could be off here, but I think it's going to be 192 cubic feet. When we go 8 times 8 times 9 divided by 3, we should get 192 cubic feet. All right? As long as that's what 64 times 3 is. Yeah, it is. Okay. So that's the volume of the pyramid, the volume of the regular sized tent. Now, question B, we have a very interesting question. It doesn't tell us how the dimensions change. Instead, it tells us how the volume changes. It says the company wants to design a larger tent that has triple the volume. Triple the volume. Determine dimensions that are going to make this possible. Determine dimensions that are going to make this possible. Okay. So, in other words, if we go back to this, we can kind of think of it this way. This is our length. This is our width. This is our height. And we want to change one or more than one of those so that this gets multiplied by 3. Okay? You can change one of those or more than one of those. This is one of those questions where there's really more than one answer. 5 of you could potentially give me different ways of doing this and all be completely correct. So let me ask you, how do you think we can change the size of the tent so that the volume is exactly triple the original size? What do you think? Maybe the only way to really do a question like this is to sit down in that sandbox and start playing. Okay? Play with some numbers. And this is not as complicated as you might think it is. So right now, the length, width, and height. The length is 8. The width is 8. The height is 9. So I'm just going to break it down to you here. Let's change one of those numbers. Okay, let's change one of those numbers. Which number can we change? Any of them. Now let's think about this though. Let me ask you about this. If you went to Canadian Tire and you bought a tent, and you looked at a small tent and a big tent, you bought the big tent. If you bought the big tent and the big tent was just bigger because it went higher, does it really matter to you if the tent goes higher? What do you think? No, I don't think so. Like, Don't get me wrong, you don't want to be hunched over when you walk into the tent. But as long as you can stand comfortably up in the tent, you don't really want it to be much higher.
Jada Wood and Janine Wood, please come to the school office.
What you want to do instead is alter either the length or the width. So it doesn't matter which one. So why don't we take the length, and if we want to triple something, that means we want to multiply it by 3. So why don't we try to multiply 8 by 3? What's 8 times 3? 24. So now why don't we try having a length of 24, a width of 8, and a height of 9. So, volume is 1/3 length times width times height. 1/3 of 24 times 8 times 9. And what do we get? 576. Now let me ask you this. Is this triple 192? Yeah, it is. So giddy up to that. So just so we're clear here, though, that like so far in this unit, we're used to the question being find the volume, find the volume, find the volume. This question doesn't ask us for the volume, it asks us for the dimensions. So now that we've shown that, yep, that works, we should write a little summary saying what the dimensions are. So therefore, length is 24 feet. Width is still 8 feet. Height is 9 feet. And that would be our answer. It would be the length, width, and height that make the tripling happen.